Hello, and I am here today to talk to you a little bit about how we make solutions in chemistry from solutions that we already have. And I think you're already really familiar with this idea, so it won't be too much of a stretch. It doesn't involve anything new that you don't already know. And you're definitely familiar with the concept if we were to talk about solutions that you would like to have in your everyday life. For example, I have a solution of some orange drink in here. So it's got some orange flavoring and it's got some sugar in it. And if I was to tell you that this particular solution is way too concentrated, like you go to take a drink of it and it doesn't taste very good because it's very, very, very strong and sweet, you would be able to tell me how to fix this, right? Like even my kids could say, oh, we should do this, right? So what would I do to fix this solution? Very good. You would add some water. So I have another container of water, and so I have my concentrated solution, and I'm going to fix it so it's drinkable by adding water. Okay. Now, as I do this, there's a couple of things I want you to notice. First thing is that when I add the water, look what happened to the volume of my solution. The solution volume went way up, right? So I started with a small amount of the concentrated solution and the volume got much greater. The other thing I want you to notice is the color of the solution. It did get lighter, right? But did you see me pull any sugar molecules or flavoring molecules out? No, right? All I did was I took my orange drink that was too concentrated and I diluted it. And so that brings us to our conversation today, which is all about dilutions. Here, let me set this off to the side before I knock it over. Okay, and I have just a teensy amount of notes for you to take while we talk about this topic. So you can snag those if you want to. And I'm going to go ahead and present my screen here. So as the title page says, when we talk about dilutions in chemistry, what it's talking about is how to make a solution from one that you already have. And this is extremely common in chemistry. Like we do this all the time as your teachers, especially when it comes to like ordering acids and things like that. We will add or we will order and pay for very, very concentrated acid, although we hardly ever let you work with concentrated acid. Once we have it at the school, we dilute it by adding water. So we aren't paying for the shipping of, different solutions and stuff like that just have a bunch of extra water in them. Okay, so let's talk about what happens when we dilute a solution. When we dilute a solution, what it means is that you are adding more solvent. And remember, our solvent is usually going to be water without adding more solute, right? Or without changing the solute. So this is like the perfect picture for you to understand. Notice that there are 6 molecules of solute in our picture. This would be called a concentrated solution. The chemistry term for this is a stock solution. We add water and notice that the 6 same molecules are there. So the solute did not change at all. The amount of solute, the moles of solute did not change. All we did was add water. Okay, and that idea is very important for you to understand. The moles of the solute before is the same as the moles of the solute after the dilution. So the moles before is equal to the moles after. Another way to think about that is that the number of moles of the solute in the concentrated solution, if you want to use that terminology, is the same as the number of the moles in the dilute solution. Okay, so the moles equal to each other, or the moles are equal to each other. Now, the other thing I want you to remember from molarity is that moles can be found by taking the molarity of a solution and multiplying it by a volume, right? So if the moles before is equal to the moles after, then we can actually plug molarity and volume into this equation, and we get an equation that looks like this. The molarity times the volume before a solution is diluted is equal to the molarity times the volume after a solution is diluted. Or we could say the molarity times volume of the concentrated solution is equal to the molarity times the volume of the dilute solution, if you prefer those terms. Okay. One quick thing I want to note with you about this equation. Molarity we know is a capital M for a unit. Volume usually is liters, but since this is just a mathematical ratio, the unit is not important here as long as it's the same. So if you had milliliters for your volume before, your answer would be given in milliliters for your volume after. Or if you know both volumes, then you would just plug in. You need to make sure that they're the same if you know both volumes. So if one's in liters and one's in milliliters, then you need to convert them to the same unit. So this here, this box in green is the equation that I want you to write down. Okay, so MV is equal to MV, where it's the molarity times the volume before the dilution equal to the molarity times the volume after the dilution. Okay, and that's it. That's all I have for you to learn today. So what we're going to do is check out a couple of examples of problems like this. Okay. So I'm going to switch you over to my document camera, and we're going to walk through a couple of these examples. If you don't have in front of you the worksheet for today's lesson, it might be good to pause and pull that up or print yourself a copy or something like that so that you have these example problems in front of you. Okay. So let's try out a couple of these. So it says if we dilute 53.4 milliliters of a 1.5 molar solution. So the first thing I want to do as I read this is I want to keep in mind, oh, my marker is dead. That's so terrible. I want to keep in mind that this volume and this concentration go together, right? And that's pretty obvious just because they're right next to each other. So if I dilute, so I'm going to add water to 53.4 milliliters of a 1.5 molar solution so that I now have a 0.8 molar solution. What's going to be the new volume? So we diluted, right? We went from a strong concentration to a weaker concentration. What I'm trying to figure out is what's the new volume. In other words, I know that water was added, but how much water was added? What did I get to for my final volume? Okay. So again, remember that the equation is MV is equal to MV, right? Where we have the concentrated solution on one side and the dilute solution on the other side. These problems are super easy. The only time I see people make mistakes is if they aren't clear on what concentration goes with what volume. And I think that it's pretty obviously stated in the problem. But if you struggle with that, definitely get a little bit of help. Okay, so we're going to say that this is my volume and molarity before, right, or for my concentrated solution. And so then this is my molarity after. Okay, so I just have to plug all these numbers in. So my molarity before is 1.5. My volume before is 53.4 milliliters. Remember, it doesn't matter what unit you're in, just as long as you understand that it's going to be the same unit on both sides. I apologize, my dogs are thundering through the house. Okay, and then so this is the before, and then the new concentration, the new molarity is 0.8. Right? And what we don't know is our volume. So I'm going to put an X. And then since this volume is milliliters, I'm going to put milliliters here. Right? So that's what we're solving for. Right? So we're looking for the new volume. Okay, do you see how simple this equation is? This is just basic algebra. And so when you're doing these practice problems and wanting to get full credit for the practice problems or for a problem on a quiz or a test, this is the minimum amount of work that I need you to show. Lots of you can just solve this with a calculator, right? You don't have to do anything special. For those of you who want a little extra kind of help, how are we going to get this X by itself? Well, we're multiplying 0.8 by X. So when we want to get something alone, we have to do the opposite mathematical function. So since we're multiplying by 0.8, we're going to divide by 0.8, right? Now, of course, math we know is fair, right? So if we're going to divide by 0.8 on this side, then we need to divide by 0.8 on this side. Okay. You can also see where our unit comes from here. We have molarity on the top and molarity on the bottom, so those would cancel each other. And whatever number we get here would be left with milliliters for a unit. So our new volume, the volume of the solution that we've just made, right? What's it going to be? We're going to take 1.5, sorry, 1.5 times 53.4, and we're going to divide by 0.8, and we get that our new volume is 100 point, and I'm going to round to the second decimal place, 100.13, and again, the unit would be milliliters. Super easy, right? Just plugging the numbers into the equation and solving for whatever is missing. Okay, let's check out a second example, example number 2. Okay, so it says if I start with 100 milliliters of a 2.5 molar solution. So again, that information goes together. And this is where I'm starting. So this is my before. If I start with 100 milliliters of a 2.5 molar solution and I add solvent, so I dilute, I add water until I have 625 milliliters, what will the molarity of your new solution be? So what's the concentration of your new solution after you add all of that water, which is essentially what I just did in the orange drink example that I showed you. Okay, so again, the equation is that the molarity times the volume before the reaction is equal, or the dilution is equal to the molarity times the volume after the dilution. Okay, so we're just going to plug all our numbers in. So our molarity before is 2.5. We're going to multiply that by the volume before, which is 100. And again, note that the unit is milliliters. After the dilution, we don't know the concentration of our solution. We just know that a bunch of water was added. So that's going to be my unknown. I'm going to put a question mark this time. You can do a question mark or an X, whatever. It doesn't matter. Just so that you know that that's what you're solving for. So I have to take that molarity and multiply it by the new volume. So the volume after the dilution occurred, which would be 625 milliliters. And again, please note that it's milliliters on both sides, so that'll work, right? It's a ratio, so as long as they're the same units, they'll cancel. Okay? So how are we going to solve this problem? And again, that's the minimum amount of work that you need to have for full credit along with your correct answer, obviously. But we want to solve for this molarity, so we have to get it alone. Since these two numbers are multiplied, what's the opposite of multiplying? Dividing, right? So we're going to divide by 625 milliliters. And because math is fair, if we do it on one side, we have to do it on the other side. 625 milliliters. Okay, so now I just have to plug this into my calculator. Nice and easy. I'm going to do 2.5 times 100 divided by 625, and I get 0.4. So the new molarity, right? The solution, the molarity of the solution after the dilution is 0.4. The concentration is 0.4. That's our final answer. See, very, very, very easy math to do. Okay, one last example, and then I'll let you practice on your own. I only even gave you 5 problems because they are so basic, like it would have been ridiculous to do more than that. So it says, how many milliliters of concentrated HCl? So concentrated would be before the solution. Just so you know, another word that we use often in chemistry for the concentrated solution is the word stock solution. So the stock solution is what we buy, and then we dilute to use whatever we need. So there will be that term in your practice problems, and that's what it's talking about. So the concentrated solution is the stock solution. So how many milliliters of concentrated HCl, if it has a molarity of 12.3, will you need to make 250 milliliters of 0.5 molar HCl? This is a really realistic problem. This is the kind of problem that I do all the time in the chemistry lab. I know the volume of a solution that I need, and I know the concentration I want. So how much of the concentrated or stock solution do I need to get out of the container in order to make this solution? Okay, so this 250 milliliters of 0.5 molar, that all goes together on the after side. So the equation is molarity times volume is equal to molarity times volume. So set up over here, we know that the molarity is 0.5 and the volume is 250. Right now, real quick side note, if you set this up and you put these numbers over here, does that change your answer? Absolutely not, right? Would it be wrong? Absolutely not. Would you lose points? Absolutely not. It's the same thing. Doesn't matter really what side it's on. Now, what would be wrong is if you put the 250 milliliters with the 12.3 molar, right? That is not the same thing. Those two numbers don't go together, okay? But you can put them on either side. So then on the concentrated side, the before side, we know that the concentration is 12.3 molar. So what the problem is asking for is what volume of that 12.3 molar am I going to need in order to get this particular solution? Now, I went ahead and wrote milliliter here because I had milliliters over on this side. And remember that the units have to be the same, okay? And so there you have it. That's the minimum amount of work that you would have to show in order to get full credit. Now let's solve it, okay? So we want to get x all by itself. Since we are multiplying x by a number, in order to get it by itself, we're going to do the opposite. We're going to divide by that number so that it'll cancel out. So I'm going to put 12.3 molar on this side. Now again, math is fair. My dog is drinking the orange drink I just put on the floor. Please do not drink that. That will be bad, I'm sure. Okay? So we're going to divide by this number, but because math is fair, we're going to also divide by that number on the other side. Okay? So we just plug this into our calculator, nice and easy. It's all multiplication and division. 0.5 times 250 divided by 12.3. And my answer is 10.6. So the volume of that concentrated solution that I'm going to need to make my dilute solution is 10.16 milliliters. Okay? Nice and simple. Hopefully not too difficult for you to figure out on your own. You now have 5 practice problems for you to do to solve and practice this calculation. When you're done, make sure that you check your answers. They're posted on the calendar and they should be in Classroom. And then if you did anything wrong, make note of it, fix your paper so that you know how to do the problem correctly. And then please submit a picture of your work for me on Google Classroom. You guys know the drill. Okay. As always, if you have any questions or concerns or need help with this above and beyond what I gave you in the video, please, please, please reach out. I'm sitting around every day waiting to hear from you guys. Okay. Have a fantastic evening, day, whatever time it is you're watching. Bye.